Hi guys, so I'm back for another video, and for today's video it is all about the activities in chapter 8, subnetting IP networks. I'm going to answer all of the activities included in this chapter. Let's start answering it. First activity is about calculate the subnet mask or basic instructions. In this activity, you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet fields provided. Additionally, convert the mask to prefix notation or /x format in the prefix notation field. Okay, let's start. Calculate subnet mask. The subnet mask is 255, the 255.128. So I need to convert it into binary. Okay, let's start. So sorry if there is an answer, I can clear it, but I'm going to type the answer because I know the answer here. Okay, so the binary of the 255 is equal to all 1, all 8 1. Okay, the next is also 1, then 1 again, then here we just need 1 in the first, in the last, in the first part, because as you see, the first is 1, then 2, 4, 6, at 1, 2, 4, 8, 16, 32, 64, then 128. So I'm just going to put 1 in the last part. So 1, then all of these are zeroed. Okay, 87 zeros. Because the last part is 128, then the given is 128. So this is 1, 0, 0, 0, and so on. Then the prefix notation is you need to count all ones here. So every part of this is 8 bits, I think. So 8 plus 8 is 16, plus 8 is 24. So we have 24. Then just add 1 here in the last part because it only have 1, because all the rest is 0. So the answer will be 25, because 24 plus 1 is 25. So it is /25. Let's check if it is correct. Okay, it is correct. Let's try another given. Okay, so then it is all 1 again. Then the same here, 1, then 1, then you just need to put in the last part 128, because 128 is less than 192. So you just need to diminish or minus 192 to 128. So 128 plus 64 is 192. So we have 192 here. So the rest is 0. Then the answer will be, the answer will be 26, because 8 plus 8 plus 8 is 24, plus 2 is 26. Let's check. Okay, it is correct. Next. Okay. Last for this activity is this all 1 again. Then same again. 1. So in this part, it is different in the 2 given here. So we just need to add 1, then 128 plus 64 is 192. So there is 192 plus so the shortcut here is just need to minus 254 to 255. So in the first part of this binary, the given is 1, then 2, then 4, then 8. So we just uh, excluded the first part, the 1. So all of these are 1, then 0. Then it is 254. Then here it is all 0. Okay, let's add or count all 1 here. So 8 plus 16, 8 plus 8 is 16, plus 17, 18, 19. Also, this is 23 because in these three parts, this is 24. So we just minus 1, then it is 23. Because in the last part, it is all 0, so it is not excluded. Slash 23. Okay, it is correct. Let's go to another activity. Okay, in this activity, we determine the number of bits to borrow. Instructions. In this activity, you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answers in binary, decimal, and prefix notation format in the fields provided. Okay, the first example is where the first given is 250. The host needed is 250. And the subnet mask or binary is all 1 in the 3 parts and 0 in the last part. Then subnet mask or decimal is 255.255.255.0 because these 3 parts are equivalent to 255 each. Then the last part is 0 because there is no value or 1 here. Then the prefix notation is slash 24 because all these 3 parts, it is equivalent or equal to 24. Okay. Let's start answering the second host. So the host needed is 25. Okay. The first part here is all 1. Then all 1 again. All 1. Then here we use a formula 2 raised to n. Okay. So 25 is closer than 32 because we use here we determine here the greater part or the greater part of the given number. Like 25 is the less is, less than 32. So 32, we need 32 here. Okay. So the last part we put 111 because 128, then 64, then 32. Here, this is a 32. Then all 0. Okay, I'm going to see or explain how it happened. So it is 1, 2, 4, 1, 2, 4, 8, 16, 32. Okay. So this is 255. The 25, okay, sorry. 255, the 255, the 255, that need to add this. So 128 plus 64 is 192. Then, wait, okay. So 128 plus 64 is 192 plus 32 is 224. Okay, the answer here is correct. But I'm just going to type here 224. So that is the subnet mask. Then the prefix notation here is /27 because 8, 16, 10, 24 plus 3 is 27. So /27. Then next, okay, let's check if it is correct because it is hard to check one by one here. Okay, so the first part here is correct. This is not just says incorrect because I'm not finished doing all the parts here. Okay, just this part is correct. Then next we need to identify the subnet mask of 1000. So 1111, then 1111. Okay, the given here is 1000 because so we need to use the third part. Okay, because in this part it is equivalent to 128. So we need to add more to reach this post needed. Okay, let's just try here putting all zeros here because this is not equal. Okay, so if you add 128 excuse me, plus, okay, wait, so if you multiply 128 to 2, it is equal to 256. So this is 0. Then multiply 256 to 2 is 512. And 0 again. So 512 is less than 1000. So we need more to reach 1000. Okay. So 512 times 2 is 1024. Okay. So 1024 is greater than 1000. So we reach this part. So all given here is 1. Okay, then let's go to subnet mask of this part. So this is 255, that 255, then add this part. So 128 plus 64 plus 32 plus 16 plus 8 plus 4. So this is 252. Okay. Then that's 0 because there is no value here. Okay, we need to count this part. So 8 plus 8 is 16 plus this part, this is 16. Then just minus here. Okay, 24 minus 2 is 22. So this is 22 slash 22. Okay, let's check. Okay, this is correct. Next. So this is 1. Then 1 again. 1. Then, okay, 75. We need to reach 75. So, 64 is less than 75. So, we need to put 128. We need to choose 128. So, there is only one here. Only given one here. So the rest is 0. Okay, let's check. 255, 255, that 255, that 128, because the last part is 128. Then count all one. So slash 25, because 24 plus 1 is 25. Let's check. Okay, it is correct. Next, house digit is 10. So 1, then 1, then 1, then 10. So we need to choose. Okay, so 2 raised to n. Okay, we need to choose 16 because 8 is less than 10, so this is not valid. Okay, so 16 is valid. So we need, okay, let's start here. 0, 0, 0, 0, because 1, then 2, then 4, then 8, and the rest is 1. Okay, next, 255, that 255, that 255, that, so 128 plus 64 plus 32 plus 16 is equal to 240. Okay, let's add all the 1 here. So 24 plus 4, because there are 4 ones here. So 24 plus 4 is slash 28. Let's check. Okay, this is correct. Last is 500. Okay, so there is 1 given here. So the last host needed is 500. So let's start. The subnet mask is 1111, then 1. So we need to use again this third part. First, we just need to put all 0 here. Then the 128 times 2 is 256. So 0 is 256 is not valid. Okay. So 256 times 2 is 512. So 512 is greater than 500. So this is valid. So we need to put all 1 here. The rest is 1. Okay. So the subnet mask decimal is 255. That 255. That 25. Oh, sorry. 254. Okay. Because there is 1 0 here. 254. Then that's 0. So the prefix notation is slash, wait, this is 24, so we need to minus 1, so slash 23. Check. Okay, all the given here is correct. So we can move on to another activity. Okay. So the next activity is practicing VLSM. Then part 2 is practicing VLSM 2. Okay, the instruction here is Table 1 uses regular subnetting to accommodate the network shown. Table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. Okay. So the IPv4 address here is 192.168.5.0/24. Table 1 first subnet calculation. Calculate 50 users per subnet. Okay. The new subnet mask in decimal is this. So 255.255.255.192. This is decimal. Because if we use binary, this is only 111 then 0. Okay, like that. Then next, first prefix notation. So prefix notation is /26. This is the prefix length. Okay. The first full subnet range is the lowest value. Okay. So this is the lowest value here, because as you see, this is 5.0. Then the other is 5.64, 5.192. Next, second full subnet range. Then the second greater value, that's 64. Next, the last is 1, because this is the greater value, the greatest value. Let's check. Okay, this part is correct. So I think we can move on to another part, the last part. So instructions. Table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. 192.168.5.0/24. Table 2 VLSM calculation. Use Table 1 second full subnet range and VLSM to calculate for 20 users per subnet. Okay, start. The second full subnet range is /26 from table 1 is, wait, okay, it's 1. Because as you see, this is lower than this part here. Next, new VLSM subnet mask in decimal. This is 255.255.255.224. Next, VLSM prefix notation is /27. Then, first full VLSM subnet range is, oh, sorry, I thought this is first, this is second. This is the first full VLSM. Then the second is this one. Sorry, I thought this is first full VLSM subnet range. Then the last full VLSM subnet range is 192.168.5.96/192.168.5.127. Okay, let's check if it is correct. So this is correct. Okay, I finished all the activity here in chapter 8. Thank you for watching. Bye.